So in this video, I'm going to explain to you what is derivative. What is the meaning of derivative? So the definition of derivative is the derivative of fx with respect to s is the function f prime s and is defined as f prime s equals to limit as h approaches to 0 fx plus h minus fx over h. And the technique that we use in differentiation is derivative of constant linear and power functions, derivative of sums and differences, product rule, quotient rule, and also chain rule.
So hi everyone, so I will be solving question 2, and question 2 is find dy dx for the following functions, and for the functions for question A is 3x squared second x plus 2. So we need to solve this question using product rule. So first we need to assume the u and the v. For u is 3x squared and for the v is second x plus 2. So we need to differentiate each one of them. So for u, differentiate of u is 6x. Why? Because we need to multiply all of 2 with 3. So we get 6. And we need to minus 2 with 1. So we get x power with 1. But we don't need to write 1 here, so we just get 6x. So for the v, differentiate of v, we will differentiate of second, we will get second time. So for this, we will get second x plus 2 times x plus 2. We already got the values for u, u prime, v, v prime. So what else do we need to do? Of course, we need to put all these values into the formula of product rule. So what is the formula for product rule? Formula for product rule is u prime multiplied with v plus u multiplied with v prime. So 6x multiplied with second x plus 2 plus 3x squared multiplied with second x plus 2 times x plus 2. So when we multiply 6x with second x plus 2, we get 6x second plus 2 plus 3x squared second x plus 2 times x plus 2 is what we get when we multiply 3x squared with second x plus 2 times x plus 2. So moving on to the question B, y equals to 4x plus 2 divided with cos x. So we need to assume u and v first. So for u we will let 4x plus 2 and for the v we will let cos x. So for u prime we will get 4 because 4x is actually 4x power to 1. So 1 will be multiplied with 4, so we got 4, and it will also will be minus with 1, so we get x power to 0. So we don't need to write here, and 2 will be 0, so we don't need to write here. So for v prime, cos, when we differentiate cos, we will get negative sine x. So we already got the value for this, so we just need to add all of this into quotient rule formula. So 4 multiplied with cos x minus 4x plus 2 multiplied with negative sine x divided with cos x squared. So 4 multiplied with cos x will be 4 cos x, and 4x plus 2 multiplied with negative sine x, we will get positive because when we minus negative sine x, it will be positive. So positive, which is plus 4x2 sine x divided with cos squared x. That's all.
Hi, Assalamualaikum. So in this video, I'm going to solve a question 3 by using implicit differentiation. So this is the original equation, and then I'm going to differentiate both sides of the equation with the respect of x. So I'm going to write d over dx times with y and 3x minus d over dx times e power of 2x plus 1 minus d over dx times tangent 4y equals to d over dx times with 0. I'm going to differentiate term by term. So for the first term, I'm going to differentiate y over 3x by using product rule. So this is the formula for product rule. U prime v plus u v prime. So u is equals to y, u prime equals to dy over dx, v equals to below 3x, and v prime equals to 1 over 3x times 3, and we can get 1 over x. I'm going to write f prime x equals to u prime v plus u v prime. U equals to dy over dx times with below 3x plus y times with 1 over x. And then we move on to the second term, which is e power of 2x plus 1. I'm going to solve this term by using chain rule. and then we're gonna solve. First is e, and then the power. So after we differentiate e, we can get e power of 2x plus 1, and then after we differentiate the power, we will get 2. And then 2 equals to 2 times e power of 2x plus 1. And then we're going to differentiate for the third term, which is tangent for y. And we're also going to use chain rule in this term, and then we will have tangent for the first different. We will differentiate tangent for y, and then after that we're going to differentiate for y. After we differentiate tangent, we can get secant square for y, and then after we differentiate for y, we can get 4 tangent divided by x. After that, we're going to write back all the terms that we have differentiated in one equation, like this. We will write dy over dx times below 3x plus y tangent 1 over x minus 2 times e power of 2x plus 1 minus secant square 4y times 4 times dy over dx equals to 0. And then we're going to simplify the term that we can simplify, which is y times 1 over x will be y over x, and secant square 4y times 4 will get 4 secant square 4y times dy over dx, and the rest we just copy back. After that, we're going to separate the term which has dy over dx at the left side, and term that do not have dy over dx, we will put it aside, like this. Dy over dx times below 3x minus 4 secant square 4y times dy over dx equals to 2 times e power of 2x plus 1 minus y over x. After we separate dy over dx, we're going to factor out dy over dx at the front, and then open bracket, then 3x minus 4 secant square 4y close bracket equals to 2 times e power of 2x plus 1 minus y over x, and then we're going to solve dy over dx, and 2 times e power of 2x plus 1 minus y over x will be the numerator, and then 3x minus 4 secant square 4y will be the denominator, like this, and then that's the answer.
Hi, I will be solving question 4. For question 4, we need to use 4 steps to solve this question. For step 1, we need to replace 80.99 with x. We need to write fx equals to 4 root x minus 2 over square root x. Then we need to rewrite the function in exponential form. X power of 1 over 4 minus 2x power of minus 1 over 2. We need to differentiate the functions. F prime x equals to x power of negative 3 over 4 minus 2x power of minus 3 over 2. We need to rewrite 1 over x power of 3 over 4 minus with 2 over x power of 3 over 2. For step 2, we need to find x1 and x2. It is because we need to calculate delta x. So, delta x equals to x1 minus with x 80.99 minus 81, we will get minus 0.01. For step 3, we need to find differential of the functions. We need to use the approximation functions. We need to substitute 81 in x1. The f equals to f prime 81 times with delta x. Next, 1 over 4 times 81 power of 3 over 4 plus with 1 over 81 power of 3 over 2 times with minus 0.01. We will get minus 21 over 290,1600. Then for step 4, we need to find approximate value of the functions. We will use this formula, fx1 equals to fx0 plus df. We need to substitute the value. f80.99 equals to f81 plus minus 31 over 291,600. Next, 2.7778 minus with 31 over 291,600. Then we will get the answer 2.778, which is 3 decimal places.
For the conclusion, techniques of differentiation such as the product rule, quotient rule, and chain rule are essential in calculus. These techniques help us find derivative of various functions efficiently. By mastering them, we can solve both mathematical and real-world problems, including applications such as rate of change, increasing and decreasing functions, minima and maxima approximation, and point of inflection. They are a crucial part of understanding and applying calculus effectively.
These are the online sources that we use as our reference. Thank you.